last but not least, in Hebrew I may say אחרון אחרון חביב, and he also knows Hebrew, is Professor Dan Boneh. He's the co-director of the Stanford Cyber Initiative and co-director of the Stanford Computer Security Lab, and a professor of computer science and electrical engineering in Stanford. Dan, please.
Great, thank you. So like my colleague said, we've been here now for a couple of days meeting with various folks from the cybersecurity industry and government. The effort in cybersecurity in the country is outstanding. It's really impressive to see what's being done here. So I guess I wanted to tell you two quick stories. So as I was introduced, I'm a professor of computer science at Stanford. I work on computer security. The first story I want to talk about is education in cybersecurity. So I'd like to just make you aware of the fact that within our university and many other universities, including ones here, computer science actually is drowning in students. It's really quite a remarkable fact that there is this, students are voting with their feet, and many are majoring in computer science. The numbers, if you look at the exponential growth in the enrollment in computer science, it's really quite remarkable what's been happening in the last couple of years. Now, we run our computer security classes. We have a whole program in computer security that's made up of a number of classes. And within computer science, computer security is one of the two hottest areas. Maybe I could let you guess what the other area is, but it's not very difficult to guess. The other hot area in computer science is machine learning, and there's actually a lot of interaction between computer security and machine learning, which maybe we can explore a little bit later on. So whenever we run our computer security classes, they are very strongly subscribed. We have something on the order of 300 students every time, and running such a large class is a fairly interesting management task. That's the impact of us drowning in students. The point I wanted to make is that teaching computer security is very different from teaching almost any other course in any area of sciences in the university. The reason is because computer security is such a fast-moving field, extremely fast-moving field, that every time we teach the course, something like a third of the material has to be updated and changed into something new altogether. So just think about it. Every time we develop our course, we're done with 1 year. The next year, a third of the material is brand new that we have to develop. Just to give a quick example, like this year we had to introduce a whole new module just on new technology that Intel deployed called Intel SGX, which is a way to run jobs in the cloud in such a way that the cloud provider can't look into what the jobs are doing. So that's just an example of how the curriculum has to be updated, and the lesson in all this is the message to you is, if you have taken the time to learn computer security and familiarize yourself with it, just be aware that your knowledge is going to become stale very fast. So sort of putting a check mark on saying, I've learned what I need is not going to work. You have to constantly be learning in the field, which, by the way, is what makes it such a fun field to work in and to do research in. I guess another way to say it is computer security is never going to get old. Yes, it's a field that's going to be with us now forever. So it's a wonderful field to go into industry in, and also to do research in. I guess the way I like to say it is, if I went to sleep and woke up in 100 years and asked, has the computer security problem been solved? I would bet anyone here that not only has it not been solved, it probably would have also gotten worse. As new generation of technologies are being deployed, we pretty much see new threats being introduced. We see this now in the IoT space, and again, that's something we can explore later on. The second story I wanted to tell you about very briefly, how am I doing on time? Okay, so the second story I wanted to tell you about very briefly is the interaction with industry. So I'm fortunate to be in Silicon Valley, as my colleagues from Berkeley, and of course MIT is also in a very active area. I would say that about a third of the papers that I write are a direct result of interaction with industry. And I just wanted to give you one simple example of this. So a company came to us, a fairly large company came to us and said, we have the following problem. We use what's called a CDN, a content distribution network, to distribute our content quickly to our customers. Unfortunately, some of the CDN devices are in countries that are deemed not trustworthy. Okay, so essentially content from this company is sitting in data centers that they don't trust. And the question was what to do about that. So the answer, when you come to me, I also work on crypto. The answer is kind of obvious. The answer is, you got to use encryption somehow. But the question is how. And so something has happened in the industry, which, I want to make sure you guys are aware of. Essentially, these days, not doing encryption is negligence, specifically, again, because something that Intel did. So Intel actually introduced encryption instructions into the hardware. These are called AES and I instructions. I imagine many of you have heard of these. And basically, they make encryption, specifically AES encryption, run so fast that actually the time to read data from memory is greater than the time to encrypt the data. Okay, so think about that. That means that there is actually no excuse for not encrypting data because it does not hurt performance because of the acceleration features that Intel put into their processors. So encryption, again, why is it such a useful and important tool in security? Again, I'm sure you all know this, that encryption basically reduces the problem of protecting data to the problem of protecting keys. Of course, protecting keys is still not an easy problem, but it's a lot easier than protecting the data to begin with. Now, the other thing that's happened is in recent years is that, in fact, not only has encryption been made cheap, in fact, encryption in the browser has also been made very simple to use. So there's something called the Web Crypto API, which actually allows websites to download code into your browser. That code, the JavaScript code, can very efficiently and quickly do encryption and decryption. So the combination of these two things actually makes it very easy to deploy encryption to the end user. Essentially, the end user in their browser can decrypt data as needed, and the performance implications are relatively cheap. So going back to this question, the design, of course, the system that we built and proposed and built essentially is, I guess I shouldn't go into the details too much, but essentially it's based on a mechanism where the data sits in the content distribution network encrypted, and because we're able to download just a small manifest file into the user's browser, all the decryption operations can happen on the browser. So effectively, we get end-to-end encryption from the data provider all the way to the browser without the user having to install any special software on their machine. So this is something that could not have been done before in a performant way, but because of these new capabilities, now all of a sudden is very practical and works quite well. So anyhow, I just wanted to give you an example of, so this has been deployed, and I just wanted to give you an example of very successful interaction between academia and industry, kind of building on what Iran was talking about. All right, I'll stop there.
Thank you.